What's going on? Welcome to part 2 of the recording for our WebEx class, or not WebEx class, but virtual class that we are running today. Let's start going through chapter 2, because I think that we need to start covering that. When does that do? Is that due on Friday?
I believe so.
Alright, so turn this stuff in. Let's start talking about these graphs. Let's see. Following students are walking home on the bus. Each graph below represents the student's remaining distance to the bus stop as a function of time. Beginning when he or she left the home, each graph is based at the same time frame. It uses the same distance units, but models a different story. The bus leaves the bus stop at the end of the time frame depicted. All right. Are all walking homes from their, all the following students are all walking from their homes to the bus stop. Okay. The bus leaves the stop at the end of the time frame. Answer associated with the question following. Explain. Okay, I see. So we got to take these pictures right here, and we got to match them to the stories. Who lives closest to the bus stop? This is actually kind of fun. Who lives closest to the bus stop? Let's take a look. What's your thoughts? Now remember, there's a 1 in 6 chance you can get it, so if you don't know, guess it. Sam, chime in. I'm going to wait for everybody. Leilani, I would say Kavika, since he gets there first. I would say Sam's right. It's Leilani. Because this y-axis represents the distance, right? The vertical axis represents the distance you are away. Let me draw that up on the board. We've got our graph here, and this represents the time, and this represents the distance, right? At time equals 0, when they all leave, because they all left from their house at the same exact time, at time equals 0, the distance that Leilani is away from the bus stop, because once the kid hits this bottom section right here, that means they're at the bus. The distance that Leilani is initially away is a lot shorter than the distance that Kavika is initially away. Does that make sense? Good job, Sam. All right, let's do this one. Who left their home the latest? What? Wait. That's right. I get it. I understand what they're saying. Leilani is the person who left their home the latest. In fact, Leilani is the only person who waited at home before they left. In fact, you know what? Instead of asking you these questions, why don't we just kind of make up stories for this? You know, the what's going on. All right. So Leilani, she lives close, right? Let's talk about Leilani. She lives close. She hung out, watched cartoons, ate breakfast, and then walked over to the bus stop. Why can she do that? Because she lives so close. Kavika, he kind of ran from his house. Kavika kind of ran from his house, and he kind of just jogged all the way to the bus stop. Did he get there early? Yeah, he got there early, and so he kind of just hung out at the bus stop. So he probably could have walked instead of jogged, but hey, he just walked. All right. Keone, what did he do? What did Keone do? He walked and then sprinted near the end. Now, I got a question. Did he walk and then just be like, oh, it's the bus, and he just started like running real quick? Or did he, what did he do? No, it's gradual. So it's kind of like stepping on the gas to your car. Like your car does when you step on the gas, it doesn't immediately go boom, right? It kind of like right. It gets like it starts slower and gets faster and faster and faster and faster. Is that what he did? Yeah. Good. Awesome. Now Tiare, what did she do? What's your thoughts? Let's take a look at this. Because I'm not even going to answer those questions for you. If we talk about the stories, I think that's much more interesting. If we talk about the stories and we hang with the stories, then the questions are moot. I would say she was, yeah, all right, yeah. She was, I would agree with Sam, actually, Elijah. She didn't speed up, but what she did was she actually kind of was like, she was like, oh, I'm late for the bus. And so she started running to begin with, and then she realized, like, wait a second, I don't need to run. And then so she just, boom, went straight into a walk. And she was just walking to the bus. Or jog or something like that. But yeah. The reason being is because you look at the slopes, and the slopes are different. And the slope for the second half of her journey right here is shallower than the slope for the first half of her journey. Because it's a shallower slope, that means she covered less distance over time. Now, was that a good idea for Tiare to do? Why? Why not? Elijah's right. She actually missed the bus. Now, had she continued with this slope at this angle right here, had she continued to go down like that, she might have made the bus. But since she got tired, maybe she's just like out of shape. Maybe she was just like, and then just started walking. I mean, that's totally Mr. Dalday right there. He's running, and then like this right here would probably be like Mr. Tate. He's right outside. This would probably be Miss Perry or Miss Sononini over there. This is Mr. Dalday. I'm running, and then I'm just like, oh, guys, I got asthma. I'm a nerd. I totally need my asthma inhaler, blah, 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 and I just start walking. Anyway, and then I missed the bus. All right. So she can look good coming over to the bus stop. Yeah, she probably stopped and put on her makeup or whatever. All right. Hoku, what did she do? She walked, stood still, and then ran. Yes, I totally 100% agree. She probably walked, saw her friend, started talking to them, and then it was like, oh, I'm gonna miss the bus, and she ran. All right. Now Kiani did what? What did Kiani do? Let me make up the story for Kiani because I let you guys have all the fun. Let me make up the fun. Kiani, she lives kind of close to Leilani, and so Kiani just starts kind of jogging out. She's jogging, right, and then like. She reaches down, so she's jogging along over here, and she reaches down, and so that way she can call her friend Hoku, right? And she looks back, and she was like, wait a second, where's my cell phone? She kind of goes like this, and then she turns around, and she goes, oh my goodness, and she sees her cell phone in the street way back there, and so she runs back. Actually, she runs all the way back home. Maybe she doesn't see it in the street. She just realized, oh my goodness, I forgot my cell phone at home. So she runs back to her house, grabs her cell phone, jumps in the door, grabs her cell phone, and then runs to the bus stop and makes it just in time. Does that sound like a good story? What I think is amazing about this, what I'm actually really excited about this, is like, just by looking at these lines, you can kind of see the story that unfolds. You can kind of see what happens in the math. But what I'm trying to show you is how math can be represented by short, small little things. And yet you can do these amazing things. All right, here, let's do this. Imagine that we have a water faucet that is pouring water into the top of these items right here. Okay? let's think about how those graphs might look. And I'll be honest with you, it might actually be kind of tough because I'm trying to think about it. Like A, I think is really tough now that I think about how would those graphs look. I can think of B, how that would look. But imagine if I put like a, all right, so imagine I had this. Okay. I had a coffee mug, and I put a water faucet at the top. So water's going in like that. You guys see the picture? And I put a little floater on the bottom of this coffee mug, and I measured the height of the floater as I filled this up. How would that graph look? So this would be h as a function of t. All right, for the coffee mug, what would that look like? What's your thoughts? I think it would be a straight positive line. Exactly. It would just go up at a constant rate. You guys agree? That's the coffee mug. All right, let's try C. That looks interesting. So instead of a coffee mug, we got like a water basin. So it's got a wider top than it does have a bottom. Okay? What would that graph look like? All right. I think what it will do is it will increase, but it will slow down. Kind of have a graph that looks like that. Almost looks like a sideways parabola. In fact, if we knew calculus, we could actually figure out exactly what that graph looks like, but I'm not willing to teach you calculus yet. Because we've got to learn algebra first. But would you guys agree? Because what's happening is that that floater would go up, but since the area that it needs to kind of cover is getting bigger, it wouldn't go up as fast as it did in the beginning. So it'd still be positive. It wouldn't go down, but it would, you're still adding water in, but it wouldn't go up as fast. Does that make sense? All right. Let's try the ipu. And it's funny is because that is courtesy of the National Music Museum of University of South Dakota. It looks like an ipu to me. Why isn't it the University of Hawaii? Whatever. All right, part D. The ipu. We got ourselves a circle with a. What would that graph look like? What time does your class start?
At 10:30.
How can your class start at 10:30 if my class finishes at 10:55? All right, guys, I gotta go.
I mean, if you still have algebra 2 kids.
No. I'm gonna end class. I have to end class because the other class starts at 10:30. See you later.